Here we go. All right, so we're getting ready to go over something that is so easy. So easy. Very simple, but what you need to understand is there's a couple of different ways to go about this. So we're going to go from now until whenever. Get it done. You're going to have homework within the class. You're going to flip out because you're going to go, and then I'm going to say even, and you're going to go, okay, good. All right? So it's easy stuff. Easy, easy. Let's look at this. And wish I'd have done this with third block, because this is way better. We're going to cover all converting. This is from section 3.1. And we're going to do two different things, okay? We're going to convert angle measures. I would do the paper. Huh?
Every time you say it, I don't think we're going to be here for it. We don't know.
Every time I say it? Well, I think the snow stick has been shook. Miss Leviner has on her holy snow socks. They're H-O-L-Y. They're not like, they're holy, not holy. Or maybe both, I don't know. But we're just going to remember and think that they are holy, H-O-L-Y. She has on her special snow socks. Miss Leviner. Miss Leviner, beside, she's in Miss Martin's old classroom. Yeah, she's sweet as day is long. Sweet, sweet, sweet. But she has special socks on, and every time she wears her socks, we are not here. I don't care when y'all play, as long as you win. So, second thing we're going to do, because that was recorded, second thing we're going to do is we're going to talk about coterminal angles. So two things that we're going to be doing today. All of it's easy, easy, easy. Okay, the conversion, oh my Lord, super, super easy. Okay, first thing we're going to look at is converting angle measures from degrees to radians. No, 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 no. This is what we're going to do today. Now we're really going to do it. Because in a few minutes, I'm going to write converting angle measures from radians to degrees. Okay? So here we go. Let's think about what we already know. Yeah. You write down everything. Degrees. What do we know 180 degrees is equal to? 1 pi. We know that 180 degrees is equal to 1 pi. Okay? Now, how would I algebraically determine what 1 degree is equal to? Algebraically, what do I need to do to that equation? I want to figure out what 1 degree is equal to. No, easier than that. Warm. I don't want to divide by 1. Attaboy, high five in the air. Damien, you go. I want to divide by 180 because when I do that, what's it going to give me on the left side? 1. Attaboy. And what I do to one side, I have to do to the other. Now, folks, look what I end up with. What is 1 degree equal to? 1 degree is equal to pi over 180. This is our conversion factor. Remember, a factor is a number that is multiplied. It's a conversion factor for degrees to radians, because there's a different conversion factor when we convert from radians to degrees. Okay? So that right there is very important to you. All of this is important. Okay? Now, the next part, which is simple, is so let's think about 30 degrees. You already know this, but we're going to prove it. We already know this from the unit circle. What is 30 degrees as a radian angle measure? It's pi over 6. All right? We already know that, but we're going to prove it. Okay? Proof without it being a proof. Mathematically, how are we going to prove it? Well, we're going to take 30 degrees, and typically I would tell you, and I always did in geometry, nah, don't worry about that degree mark. Who cares? Okay, but you got to care now. And there's a reason. I can write any number over what? 1. I can write any number over 1 and it never changes its value. Remember I said it was a conversion factor. Factors are numbers that are multiplied. Now, you're going to see in just a few minutes, there's a reason I want you to have that degree in there. The conversion factor for converting from degrees to radians is what? Pi over 180, right? Now, I do not want to memorize this. There's a way I'm going to show you here in just a few minutes that's going to keep you from memorizing it. But when we're multiplying fractions, folks, can't you cross cancel sometimes? Now, as odd as this is going to seem, can I cross cancel out my degree marks? Sure I can. If it were, remember converting like meters to feet and feet to inches way back in the day? Y'all remember doing that? And you had to put the right thing on the diagonal so they would cancel each other out? That's the same concept. At this point, you can cross cancel like normal. 30 goes into 31 times. 30 goes into 186 times. And then you just multiply across, and sure enough, we're able to prove 1 times pi is pi, 1 times 6 is 6. And sure enough, we're able to prove that 30 degrees is equivalent to pi over 6 radians. Okay? Simple enough, right? You prove this one. Same concept. Prove that 45 degrees is how many radians? What is it? Pi over 4. Prove it. Show me the work. You do for this? Yes, you have to put 180 on the bottom, and here's the way I remember that. So I'm going to go 45 degrees over 1, right? If I have degrees on top here, then I want to have my degree number on the bottom, which has to be 180, which means pi has to go on top, okay? Now, if you don't know that 45 goes into 180, then here's what you need to do. First of all, my degrees cancel. So now I'm in terms of radians. And some of you will not see this, and that's fine. Multiply across. And you got 45 divided by 180. Folks, put this in your calculator. It'll just make it easier and quicker. 45 divided by 180. Enter. Math frac. Enter. And it'll give you 1/4, won't it? Okay? Because it changes, it reduces the fraction for you. Okay? The math frac will reduce the fraction, and then if I get 1/4, then I know that my answer has got to be not 1/4, but pi over 4. Okay? If you were to math frac something and get 7/6, then our angle in radians would be what? 7 pi over 6. I'm just trying to make this easier for you by utilizing, I don't want us to spend our time doing fraction work, okay, when I can quickly put it in my calculator, math bracket, and I'm done, okay? That's not where I want you spending your time. Questions on this? Facile or difficile? Muy facile. See, are you ready for a test? Like, bring it on, right? Bring it on right now. Bring it on right now. How about this one? Because they're not always this easy. Convert 18 degrees into radians. And when you get done with that, do this one. It's at the bottom, at the very bottom. Negative 135 degrees. Don't let me bite you on that one. Do both of those. All right, everybody ready? All right, so 18 degrees. Conversion factor is pi over 180, right? Degrees cancel. Folks, if you cross canceled, 18 goes into 18 one time. 18 goes into 180 10 times. Did you get pi? Oh, Lord have mercy. I hope you didn't get that. Did you get pi over 10 radians? How many? Hands up. Rock on. Very good. High five. At you. What about negative 135? Say it again. It's just negative 135 over 1. You're right. Conversion factor doesn't change, right? Still pi over 180. And you may not know that 45 is the largest number that goes into both of these. But if you math bracket, 45 goes in 135 3 times, 4 times, cross out, cross out. What do I end up with? Be careful here. Atta girl, Leslie. Negative 3 pi over 4. You cannot disregard that negative symbol. Why? What's it telling us? That I'm rotating that angle down and not up this time, right? You cannot disregard that negative sign. Okay? Questions at all? You want your test tomorrow, right? Count twice? I'm just saying. Okay. How about let's go the other way? Let's convert from radians to degrees. Convert from radians to degrees, so we're going the opposite way this time, okay? So let's think. 1 pi is equal to how much? 180 degrees. And I want to find out what 1 radian is equal to. So what do I divide by this time? I divide by pi. What I do to one side, I have to do to the other. What's that give me on the left side? Bless you. That gives you 1 radian is equal to what? 180 over pi. So we've got 2 conversion factors now. This is the conversion factor, the number that we multiply when we're going from radians to degrees, okay? That's the conversion factor we have to use. Now, in my little head, that's where I would get screwed up, okay? And I have to pay attention to what I need on my diagonal. I don't want you to clutter your brain with a bunch of little tiny facts when if you'll just make one little connection, it's nothing really to memorize, you just remember, okay? Remember that if I were to have, let's use something we already know, pi over 3. Now you already know this. You already know this from the unit circle. Pi over 3 is equal to how many degrees? 60 degrees. Let's prove it. Pi over 3. No, not equals. Times. What do I need on my diagonal this time? Say it again. I need my pi on the diagonal, 180 on top, because what do I want to happen? What am I going for? I want my pi's to cancel out. Heck yes. What's 180 divided by 3? 60. So I did prove it, right? All we're doing is the same thing we just did. You loving this? So how many more examples are we going to have? That's what y'all are thinking. 400. 43. 43. How you do this one? Negative 7 pi over 6. Convert that one. Do not disregard the negative symbol. What's my conversion factor? What do I want on the bottom? I have to have on the bottom. I got to have my pi on the bottom, which means 180 is on top. The pi's cancel. Folks, you're just multiplying fractions. What is negative 7 times 180? Is that it? Okay. Divided by 6, which is negative 210 degrees. Is that right? Yes. Can you cross cancel the 6 and the 180? Absolutely you can. That's just you're doing your reducing in the problem. I just did my reducing for whatever reason at the end of the problem this time. Okay? Questions at all? Hey, what if this one deserves a star? What if I'm dealing with this right here? What's this talking about? 5 radians. What the world? 5 radians. What's missing? The pi's missing. So what does this mean? Is it? What kind of unit circle am I talking about? 5 radians. What in the world? Where would I find 5 radians, and where have you possibly seen that before? That little tick thing. Okay, draw this. This, when you just get a real number, radians, no pi involved, that's no fun. Remember, this would be somewhere, if this is 6.28 over here, then I don't know, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is from the tick mark unit circle. I don't know what 5 radians is, but if I think about that tick mark unit circle, then I'm like, oh yeah. That's this angle right here, okay? It's that one that has been rotated all the way over. So I know that when I convert it, it's got to be between 180 and 270 degrees, okay? Do you guys agree with that? It has to fall within those two parameters, those two boundaries, because here's 180 degrees and here's 270 degrees, if I were thinking in terms of degrees. Now, does the conversion factor change? No, the conversion factor doesn't change, but now I don't have a pi, but I'm going to put an R in there to remind me that I'm talking 5 radians. Because of my tick mark. I don't know if it's in the third quadrant or not. The way I just drew this means if you were to pull out that unit circle with the tick marks on it and you were to look, you would find the 5 and draw the angle. According to my pitiful little picture, I don't know if it's going to be here in the third. It's in the fourth. Well, look at the unit circle. Okay, I just messed up where I drew this, okay? Look at, get your tick mark unit circle out. Your tick mark unit circle. Okay, so retract my picture. I just threw the beautiful one up there. Hallelujah. If it's y'all know, if I draw something, it ain't going to be accurate. You ought to know that. So thank you, Damien, for saying, no, it's in the fourth, okay? This is using the real number unit circle, okay? This angle 5 radians is going to be all the way over here to this angle. Do you agree with me? Okay. It's in between. It's not in the third quadrant. It's in the fourth. So now my angle that I'm going to find, that I'm getting ready to convert, has got to be not between 180 and 270 like I incorrectly drew earlier. It's going to be between 270 and how much? 360. You with me now? Got it? No, you ain't got to redraw anything. Okay, it's on the recording. This is official. Now, let's convert. Again, I put the R at the top because I need to know where my pi needs to go. The pi has to go on the bottom. Because typically, if I start with radians, I would have 3 pi over 4, or pi over 2, right? So my R cancels with nothing. So let me undo that. And I'm going to have nothing other than multiplying across. What's 5 times 180? What's 1 times pi? Folks, you got to use your calculator, okay? And you need to use the pi button. There's the pi button. The pi button is right underneath clear. You'll have to second the caret button, okay? And all you're going to do is say 900 divided by pi, bless you, and it's going to be equivalent to a decimal. That is totally fine. We're going to round it to the nearest hundredths. Tell me what that number is again. No, it's 4/8. 4/8. If I rounded to the nearest hundredth, it would be 4/8. Thank you. Okay? Don't be thrown when you're given this number in real number terms. Okay? Questions at all on this?
Does the radians not carry over? Like you want to do 900 radians?
No. No, I use this. This R right here is mainly for me. That's like a note to self that, hey, we got radians here, so I got to put my pi symbol in the bottom of my conversion factor. Question? Other questions? No? Questions at all? You cool? Okay, let's keep going. Roll on. Go on, Miss Perry. Finish it, right? Here we go. Hey, helpful hints. Just to recap, because I don't want it to be said that you can't understand the notes, because you better get this. If we're going degrees to radians, then let's say we had 30 degrees. What do I have to have on the bottom to convert? I got to have my degrees on the bottom. Folks, I'm looking for the degree symbols on the diagonal, okay? If I'm converting from radians to degrees, and let's say I start with pi over 4, then what do I want on the bottom of my conversion factor? Pi. This is something I don't have to think about, because if they're on the diagonal, they cancel out. I multiply, I divide, simplify rather, and I get my degree measure, okay? Just a real quick way to recap how to convert these radians to degrees, degrees to radians. Is it this easy? Yep, it's this easy. It really is. There are no catches. The only catch is that 5 radian type problem. That's the only catch. Now, let's go to coterminal angles, changing gears completely. Coterminal angles. Coterminal angles are 2 angles that share the same terminal side. Coterminal angles. are two angles that share the same terminal side. So what's that look like? Say it again. No. This is like angles that have aliases, right? And you've heard me talk about this. Aliases, AKA. Because here at this school, I'm referred to as Miss Perry, right? When I'm at home, I have another name, Mama, or hey, right? Hey. But I have different, and you guys do too, okay? You have different names. You have nicknames that you go by. My little mama, God bless her. She will call me Hopi until the day I die, until the day she dies. That is what she will call me forever and ever and ever. Doesn't matter how old I am, that's what I'm still Hopi to her, okay? Now, that being said, that's what this is like, coterminal angles. Think about this. What would be another name for a 90-degree angle? And you better not say right angle. What would be another name? Who? Pi over 2. Oh, okay. But what would be another name? Nope. If we go 90 degrees or pi over 2, isn't there another? That would be rotating which way? Up. Okay, think about it. If I think about this angle right here, pi over 2, and that's a positive rotation, there's another way to get to that angle. What's the other way to get to that angle? Oh, looky, 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 looky. Easter. If you rotate down, then negative 3 pi over 2 is the same angle. It ends at the same, it's not the same angle, but it ends at the same place, okay? They share the same terminal side. Now, because every angle starts here, that's your initial side. This is your terminal side. But it's kind of like a different way to get there. Different way to get, bless you, to that angle. Now, how do you do this? You do this two different ways, folks, and it's so easy. If you determine whether two angles are coterminal, now y'all know I'm all about the pictures, right? Determine whether two angles are coterminal. Let's look at this first example. We've kind of already looked at one without really saying, hey, this is an example. But let's look at this one. Let's look at 40 and 400 degrees. Now, up until today or yesterday, what is the only thing I'd have done? The only thing I'd have done is I'd have had to do a what? I'd have drawn a picture. And for your notes, this is what I want you to do. Draw the picture. Okay? Just for your notes, because this is probably the last time you do this. Okay? The first way would be to draw the 40-degree angle. There it is. Where's 400 degrees? It's 360, which is all the way around, plus how much? 40. So look at me using different colors. Isn't that clever? 360 plus 40 is 400 degrees. Folks, do these two angles land or end at the same spot? Yes. Are they coterminal? Yes. I can physically see that these two angles are coterminal. Happy, happy, happy. But how many of us are overdrawing? I am. Jansen, thank you for your honesty. Here's the second way to do this. This is using a graph. Let's crunch some numbers, okay? Using math. This is the only one you have to do this for, okay? First thing you have to do, you find the difference between the two angles given. Find the difference between the two angles given. What's that mean to do? Subtract them, okay? 400 minus 40 is 360, right? Okay. That's a good thing. That's a very good thing. Because if the difference is 360 or any multiple of 360, then the two angles will be coterminal. Get out of the way so you can write that down. If your difference is 360 or any multiple of 360, then those two angles will be coterminal. What does that mean? That means that your difference has got to be 360. Say it again. 720. Keep going. Who is it? 1080. How are we getting these numbers? You just say keep adding 360. I could also go the other way, couldn't I? Isn't negative 360 a multiple of 360? Isn't negative 720 a multiple of 360? Yeah? What number am I not talking about? Why? Well, put dot, dot, dot over here. Let me move this. So let me move this. Okay. Let me move this. Why am I not talking about 0? Because I got the same angle. If I subtract 40 degrees minus 40 degrees, that is 0. It's the same angle. Are they coterminals or are they the same angle? Well, they're the same angle. Why would we care if they were coterminal? You understand what I'm saying? Okay? So, if they're any multiple of 360 or 360, then mathematically they're going to be coterminal. I know this is what y'all are going to do. I know it is. You're going to subtract and you're going to go with it. Okay? How about this? How about seeing if negative 40 degrees and 320 degrees, see if they are coterminal or not? And I don't care whether you graph it. I don't care whether you figure it out mathematically. Do whatever you need. Did anybody draw a picture, whether it's on paper or in your head? Yeah? What do you do mathematically? Are they coterminal? Why? Because it equals 360. Watch this. Negative 40. It's going to be down here, right? Isn't positive 320 that way? Okay? Mathematically, yep, they're coterminal. Graphically, they are coterminal. Mathematically, negative 40 minus 30 is what? Shut the door. That's not what. Sorry. Negative 40 minus 320, my bad. It's what? Negative 360. It's negative. Okay. Okay. So It doesn't matter, right? I don't think so. Well, if you do it this way, if you did it this way, thank you. Okay, okay. My God. Then we still get 360, so it's all good. It's still 360 or a multiple. Yeah. No, your signs won't mess you up unless you make a careless mistake, like I just did on the board. And it's recorded forever with my million views. You will, that's right, you'll learn what not to do. That's exactly why I did that. Very good class for catching that mistake. You won't make that mistake. Hey, are they coterminal or not? Yeah, they are. Coterminal. Okay? Is this it? For real? How about this one? Hey, what would happen if when you subtract the numbers and you get 285? Then it ain't coterminal. You're right. What if you subtract the numbers and you get 1? Then it ain't coterminal. And that is an acceptable answer on my test or quiz. But it will not. It ain't coterminal. It ain't. It ain't. How about this one? Where is it? There it is. How about 20 degrees? Positive 20 degrees. And 1100 degrees. Woo-wee. How come? What are you going to do? 1100 minus 20 is what? It's regular. You can. It doesn't matter. No, it doesn't matter. It ain't. It doesn't matter. It doesn't matter. No. It ain't, Leslie. It ain't. Look, either way, are you going to get a... Now, look, if you didn't know that 1080 was a multiple of 360, how could I figure that out? Could I take 1080 and divide by 360? Yeah. And if you get a nice number and no decimal, then that would be happy, 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 right? Duck Dynasty is awesome. It is. It is. It is coterminal, Cindy. It ain't. It is. It is. It is. Okay. Then we only gonna write C. I'm just kidding. Here we go. When you're given conditions. Look, if I want to give you 43 problems of addition, I will give you 43 problems. Don't be hating on these notes, because I better not have any of you coming in here and going, I don't understand. When you got some good notes here. I'm just saying. I'm not bragging. I'm just stating a fact. These are some good notes. You guys are getting the best notes. Aren't you lucky you're not third block, right? Here we go. Now, y'all are getting the best notes today. When given conditions to find coterminal angles. Or those C angles, if we don't want to write coterminal. Here we go. What if I told you this? No boundaries. No boundaries. Why is this a no boundary problem? Because this is telling you to find what? All? Find all. Find all of them, really. Oh, you could go to infinity. both ways, negative and positive infinity. So, do we want to work problems like these? No. We want boundaries. Folks, this is a lesson in follow your parents' rules. It is not YOLO. YOLO is stupido. That's from one mama to you. Follow the rules. Don't be writing C on your paper. Don't be putting a smiley face on your paper. Don't write yes on your paper. Follow the rules. But we are going to find all coterminal angles. Go to positive infinity. What's the next number? How do we even get the next coterminal angle? Add 360. There we go. What's 360 plus 45? 45. What's the next one? Add 360 again. What is it? Something big. 765. And no. Okay. C. Oh, happy face. That's what I'm going to put. It can go on and on and on. I got to go the other way too, though. Pardon me? Now we're minusing it. Yes. Yes. So I'm going to take 45 and I'm going to subtract 360. What do you get? Negative. That's right. Minus 360 again. You get negative 675. And then dot, dot, dot. Because like you said, there are an infinite number. Okay? Of positive and negative. Coterminal angles. We don't want to list them all. We want boundaries. I'm telling you, you want boundaries. Okay? But there are an infinite number. So we've got to have some parameters, folks. Okay. We got to have parameters. Easy, folks. I want you to find two positive, stop talking, and two negative coterminal angles for 20 degrees. Go. What did I do with 20? Add 360. I know what you guys are going to do. You're going to add this in your calculator, and that's fine, okay? I've got to put, I can't just throw numbers up here. I could, but I don't want to. Did you get 740 for the next one? Okay. And then my two negatives, I'm going to subtract 360, and I get negative 340. Now, why am I putting plus 360, plus 360, minus 360, minus 360? What am I actually showing? How I could rotate to get it. This one, I'm rotating one time, right? This one, I'm rotating twice, and that's what I'm showing by doing this way. You don't have to, but I'm showing you that. What is 720? It's negative 700. How many of you had those four correct? As long as you got those four, that's all that matters. Hey, what have we not dealt with? We've been dealing with degrees a lot, right? How about radians? Find one positive and one negative coterminal angle to 3 pi over 4. Now we're dealing in radians, okay? Because we got to go backwards and forwards between them and it not be a big deal. I can't add 360 this time. I got to add what? I got to add or subtract 2 pi, not 360 degrees. Because this is in terms of radians, okay? And folks, you're going to use your calculator, and that's fine. Put your calculator. 3/4 plus 2, math frac, and you don't have to figure out the like denominator. This isn't a big deal because y'all know I love fractions. But if you're a fraction person too, I know I've got to have like denominators. What will my numerator be? If I change 2 pi into something over 4, what's it going to be? 8 pi. And that's going to give me what angle? 11 pi over 4. If I want to find that negative coterminal angle, then I'm going to subtract 8 pi over 4, and it's going to give me negative 5 pi over 4. Do you guys get that? Do you understand? 8 pi over 4 is equivalent to 2 pi. So I know that if I have 4 in my denominator, I've got to have like denominators. Okay? 2 pi is equal to what? 360 degrees. I can't use 360 now. I've got to use 2 pi. If I start in radians, I end in radians. These are good questions. Does everybody understand how to put this in your calculator? If you're not really digging the fraction thing, do you understand how to put this in the calculator? Do you want to see it in your calculator? Yes, okay. Okay, calculator, here we go. Even if I just wanted to go 3/4 minus 2, I don't want to think about what over 4. I don't want to do that. 3/4 minus 2, that's 3/4 pi minus 2 pi. Ooh, yuck, decimals are the devil. Math frac it. Hello, negative 5 pi over 4. Use your calculator, folks. No, because you're going to throw the pi in your final answer. You know it's got to go on top, okay? I'm fine with you using the calculator. I don't want you to get caught up in, oh my God, I hate fractions. I can't do fractions. And then get the problems wrong because you can't convert fractions. Just use your calculator and math frac it. That's why you have Texas Instrument calculators, because they're the easiest ones to deal with, okay? So just use the calculator. This is a good thing. You should know your fractions, but we're past that. Here's another one. Find a positive and a negative coterminal angle for 3 pi over 7. This is where some of y'all will blow that calculator up. How many of you used your calculator, just out of curiosity? All right, that's all good. It's all good. 3 pi over 7 plus 2 pi. Did you guys get 17 pi over 7 in your calculator? Yes. And then 3 pi over 7 minus 2 pi. Did you get negative 11 sevenths? A different type of parameter that you would be given might look like this. Find an angle between 0 and 360 that is coterminal to 880. What is the boundary given? 0 to 360. Whatever we find as our answer has to be between 0 degrees and 360 degrees. So Quentin, how in the world? Where are you going to do all this work? You're going to do every bit of this in the calculator, folks. How are you going to do this in your calculator? Well, how are you going to get to 360? Well, we got to minus something, right? So I'm going to take 880, and I'm going to take away 360. All right, now watch what's going to happen in the calculator. 880 minus 360. Oh, yes, 520. That's my answer, right? Why not? Because it's not between 0 and 360, so we're going to minus 360 again. Hey, do I have an answer that is acceptable? Do I have an answer that is falling in between 0 and 360 degrees? Fossil. All right. Now, hold that thought just a second. Hold on. What was the answer? 160. Ask that question again. What do you think? Yes. Yes, you will. Absolutely. So let's look at one like that. Hey, just out of curiosity, and this just makes it fun. This is a race. Go. Find me an angle between 0 and 360. That's coterminal, and you have to write this problem down because you don't want to be a cheetah. Find me a coterminal angle between 0 and 360 that's coterminal to 11,265 degrees. I triple dog dare you. Who's going to get it first? This is what I'm going to record. Watch this. 11,265 minus 360, right? Okay. All right. Minus 360 again. Oh, looky, looky, looky. Whoops, I went too far. Oh, so my answer is negative 255, right? No. Why not? Because my answer's got to fall between 0 and 360. Oh, do you want to see that again? It does work. You just watched me do it, but you had to prove it to yourself. She's right. It works. Find the coterminal angle to negative 415 pi over 4. What? Told you it's going to make you cry. Now, let's think about it. Don't make this difficult. Think about what we went over at the first part of class today. So, what did we do at the very first part of class today? We converted from radians to degrees and degrees to radians, didn't we? Bless you. Folks, let's just be honest. Now, I could totally do this as add 2, add 2, add 2, I think. But, let's see. Parentheses, because I have to be a parentheses ninja. Negative 415 divided by 4 plus who? Plus 2. And you might have to plus 2 one more time. Oh, yeah. Look at there. I'm getting close. Let's see. Oh. 0.25. Is 0.25 between 0 and 2? Yes or no? Yes. All right, now, if you have a brain fart and you're like, I don't know what that is, because I'm assure you, you are not going to leave that as your answer, 0.25 pi. Nuh-uh, not happening. You're going to take 0.25 if you have a brain fart, and you're going to, I think, math frack it. Yeah. 0.25, math frack that number, and it will tell you that it is 1/4, which means, what is my coterminal angle? Pi over 4. Did you see that? Why would I add 2? You tell me. Why do I add 2? Because 2 pi is equivalent to 360 degrees. And instead of adding 360 degrees, because I'm starting in radians, then I'm going to take negative 415 divided by 4, and I have to add 2 pi. I don't want to throw the pi in there, so I'm just adding 2 each time, okay? And then it just Just keep hitting enter because it's got that number. Luke, you said, I just find the trend. This has the trend in it. The calculator already has it in there.
Would you get the same answer if you did the top?
I don't know. You'll have to try that. I don't know. Okay? Questions at all? Calculator, calculator, calculator. What's another way you could do this if you weren't understanding that concept of adding 2, adding 2, adding 2, adding 2? You could change radians to degrees, then add 360, right? But what do you have to be careful about at the end? What do you have to make sure that your answer is at the end? But at the end, you'll need to convert back to radians. Okay? At the end, you will have to convert back to for me, and you're going to use your time wisely. You're going to look at page 184. And you're going to do 5 through 8 and 12 through 40 even. Okay?